Hello and good morning or good evening, wherever or whenever you're watching this. Today, we're excited to share with you a new product announcement that has been years in the making. My name is Gilad Golan, and I'm an engineering director in GCP Security working in confidential computing. With me today is Nelly Porter, the lead product manager for confidential computing. Later, we'll be joined by Morgan Akers, Director of Data Protection at JP Morgan Chase. So, Nelly, let's start from the beginning. What is the data protection problem our customers are facing today?
Thank you, Gillan. Really, really great to have you here with me today. So data protection problem is very important problem for customers. And again, all this time, they had and understood how to deal with this problem. The data customers collected was on their data centers, and they know who accessing this data. They had really good physical perimeter across this data. They can control not only access but also policy that can be applied to this data. And they knew that they are responsible to protect this data. So no again big news there. Everything is what is familiar as and expected. Moving forward with exabytes of data that our customers collected, it's becoming more and more difficult to keep it on premises. So they definitely looking forward to utilize cloud power to process this data. But then the situation and security assurances becoming a little more fuzzier and more difficult to maintain because sensitive data is located not only in one place that they have full control over on premises, but also on different public clouds. And what they understand that they have now shared responsibility for protect this data. So not only they are in control, but also they need to share this responsibility and control with cloud providers. So the situation becoming a little more complex. And as a result of that, there is multiple questions and challenges that our customers started to come up with and trying to address. And if I will summarize what I hear loud and clear from my customers, their concerns are around very basic topics like I have plenty of sensitive data. I need to bring it to the cloud. How I will protect it? And it's not only about data. They develop significant amount of IP and their application and algorithms have to be protected as well. So how I will do that? How will I stay compliant with all regulations and all other rules and auditors requirements that I have to deal with? Because it was a little bit easier when I control end to end all my protected data and all my sensitive data. But now when I am moving this to the cloud, it's becoming more challenging. But it's not only difficulties, it's also ability to open a new, very exciting use cases that were not possible before. For example, the case of or use case of collaboration. How I will collaborate with so many companies that I want to and have to without a need to share my sensitive data and control over that with all of them? Because some of them may be even my competitors, and I am not fully trusting them with my sensitive data. How would I be able to process it together with them and take advantage of the results of this collaboration? And also, very, very important question for all our customers. They are custodians of the data of their own clients and their own users, and they want to do their task and job right. They want to protect their data end to end. So, Gilad, with all of those challenges, is there any magic solution that you would be able to offer us?
In fact, Nelly, yes, we do. So, we at Google believe that the protection of sensitive data is paramount, and encryption is a good mechanism to accomplish this goal. We supported for years encryption in transit when our customers ingest the data to bring it to the cloud. We also support encryption at rest for data stored in the cloud across all services. Encrypted data in transit and at rest is great, but it is not sufficient. Customers bring the data to GCP for a reason. They want to index it, they want to query it, they want to train on it or infer on the data for their specific needs. So, to complete the data protection lifecycle, you would like to be able to protect data when it's being processed. Confidential computing is a new model that aims to close this gap. Confidential computing means encrypted data in memory while processing it. So, with confidential computing, customers get encryption in use in addition to encryption at rest and in transit. So, Nelly, let's get to the point. What are we announcing today?
Yes, Gilad, we will announce our creation right away, but give me a few more seconds to have some fun. Let us dream a little bit. What if, with whatever we're going to announce literally right after, with single beautiful checkbox, you, my dear customers, you would be able to encrypt all your workloads that you run previously and again enjoyed so much and make them confidential. Simply transform them into confidential environments. What you don't need to pay significant performance and latency tax of doing this transformation. And what if for some of you who have to provide audit reports to your internal and external auditors, you will be able to do it very easily. All of that about your workloads. What if all of that will become reality? And it's exactly what we want to announce today. After some really serious work that we've done together with our partners, AMD, we today announcing confidential VM on N2D series that powered by second generation AMD EPYC processors in beta. So Gilad, tell us what is that? What is confidential VMs all about?
So, what is confidential VM? Key thing to remember, it's just like a regular VM. Customers can run any workload that they usually run in VMs, and by clicking a single checkbox, they will transform their VMs into confidential VMs. When they do that, all memory pages of the confidential VM are encrypted. So you may rightly ask, if they're encrypted, how does the CPU process them? So data is encrypted in memory and is decrypted when it's fetched from memory to the CPU chip. And what about the encryption keys? The keys are generated in hardware on the CPU. They're ephemeral, they're not persisted anywhere, and cannot be extracted from the CPU chip by anyone, including Google. Each VM memory is encrypted by a unique key to that VM. And confidential VMs can scale to meet your needs, up to 224 virtual CPUs and 896 gigabyte memory. So finally, customers can protect their data end to end, from data in transit to data at rest, and finally to data in use.
Yes, Gilad. The way how you describe the key protection is very important for confidential VM. Ability for us to use hardware generated keys. Is it not extractable? Is very, very nice property. It means nobody, including Google or AMD, would be able to get access to that. Any other security capability and threat mitigation ideas that you believe we will provide to our customers with confidential VMs?
Well, as the name implies, it simply adds confidentiality while processing data. That means the hypervisor, administrators, neighbors, and malicious devices cannot snoop your data while it's in memory. As a multi tenant cloud provider, isolation has always been a critical component of our infrastructure. Now, with confidential computing, this isolation is getting cryptographically reinforced. Nelly, can we see a demo of confidential VMs?
I would love to show the demo, Gilad. Thank you so much for asking. So, first demo that we will have today is to demonstrate to our customers, our viewers, how easy it is to create confidential VM. And as we promised initially, it would be simple checkbox, and you would be able to transition your normal, usual VM to confidential VM. Let me show you how it can be done. So first, you come into usual GCP console, and you give the name for confidential VM, and you will find a new checkbox, literally checkbox, that will explain that by clicking this checkbox, your configuration will be set for your VM, and all what you would need to do is simply say create. And that's it. And your confidential VM is up and running. And to prove to you that it's confidential VM, let me SSH to this VM and show it to you that it's running on AMD server with secure encrypted virtualization enabled. And it means all your memory is going to be encrypted when it will process your code or data. The second demo that I want to show you is slightly different. As you remember, we were discussing performance and latency tags. So I want to demonstrate you that based on what we've done so far and all testing and benchmarks we've done, we've seen that we reached the envelope that we were putting on ourselves, not more than 10% performance degradation. So we've seen even the results on some of benchmarks that we've done together with A&D teams that we are somewhere around 2 to 6%, even better that we actually put on ourselves. But every single customer need to check. Please check your own workload and your own performance benchmarks to see where you are. But let me show you this quick demo. And the demo is showing you very interesting race. We will have two VMs that will start in the same, almost the same time. Non-confidential VM will come a little bit later than confidential VM. But to show you how these two will perform, first of all, let's show you that on the right side of your screen, you will have confidential, left side is non-confidential. And we will use sysbench, the performance tool, to validate memory access. Memory access is very important way for us to check how confidential VM will perform compared non-confidential. And because we're measuring throughput, as you can see, comparable is great, and the bigger number is better. We've done memory read, now we will do memory write, and let's see how these two VMs will perform. And as you can see, both of those VMs, confidential and non, are performing very comparable. So we didn't see too much degradation, but as I said, please validate your performance results on your specific workloads and let us know where you are.
Our announcement of confidential VMs today is just the first step. We believe that confidential computing will and should be part of every enterprise cloud deployment. Realizing this ambitious goal requires collaboration across the entire industry, both cloud providers, hardware manufacturers, and software vendors working together to define standards and advance the technology. This is why Google was among the founding members of the Confidential Computing Consortium operating under the umbrella of the Linux Foundation, together with other key players like Microsoft, Intel, AMD, ARM, Alibaba, IBM, and many others. We are working together to advance confidential computing. And now, I'd like to hear the perspective of a cloud customers. I'd like to introduce Morgan from JP Morgan Chase.
Gilad, I want to add one more interesting tip. Morgan Akers, that will join us right away, is also part of Confidential Computing Consortium. He is representing customer voice in this multi-industry consortium. So it will be very interesting to hear from Morgan how he was doing and what is the learning he had from working with our original preview. Morgan, now it's you.
Thank you very much, Nelly. I appreciate the introduction here. My name is Morgan Akers, as Nelly mentioned. I am a director in the cybersecurity space inside of JPMC, and specifically in the Data Management and Protection Organization. If you look at JPMC, it's one of the oldest financial institutions in the world. They work across the geographies into a global company, multiple financial sectors, customers ranging from consumer banking to corporate services to government services to asset wealth management. So really they run the gamut in terms of financial sectors. Additionally, we have a wide swath of both employees in terms of different types of roles as well as customers. And so when I think about managing and protecting our data as a mission for data management and protection, it's really how do we enable data to be managed correctly and succinctly across the firm seamlessly and without expertise. What I mean by this is, as a user of the data, you shouldn't have to know explicitly what to do with this data. The system should manage it for you. You shouldn't have to be expected to understand that this data set is this sensitivity and I know how to actually manage the policy. You shouldn't rely on tribal knowledge. This should be something the system handles for you. And when you think about that seamless and frictionless experience of managing the data, that is really the pillar that we build on in terms of maintaining the chain of trust between our users and our services and how to use that data. Now, data management and protection is really effectively three different pillars in terms of how we actually think about our architecture. The first one's classification. Classification is really the simplest piece of understanding what kind of data you're dealing with, who generated it, what kind of data it is, sensitivity level, is it business impacting, is it critical data, as well as what type of data is it? Is it programmatically generated by a service? Is it hand authored like an email or something that's a Word document? And how is it used and where is it coming from? So with that classification of that data, with as fine-grained a classification as we can get, we move to how we do our policy and decision engines. Now, for every piece of data based on the classification, we want to create a policy that says, given this type of data and who's using it, what I should do. That's the decision aspect. And we really want to do it from both a build time perspective as well as a runtime. And what I mean by that is that it's not just when I'm programmatically building my system in terms of managing the data as I build my developer toolkits and my systems across the financial institution, but also at runtime for that real-time decisioning process where influx of data comes. You need to be able to make those decisions on the fly and apply that policy. Once that policy is applied and a decision is made, you move to data handling and enforcement, which is essentially, what do I do now? Is the data encrypted? Is it do you make it readable by that individual or that service? Is it editable by that reader or service? Can you use a token? Do you need to decrypt it? Those are the aspects of what I would consider data handling enforcement. So these three things together form the backbone of what we think about for data management and protection. Now, when we look at confidential compute as an environment, as a what I would consider an area to grow and think about strategically, it's still somewhat in its infancy. So our approach to confidential computing is, what do we think we can use it for that would inform us of a decision, and how do we then incorporate in our strategy? So when we're looking at our confidential compute environment, one of the things that we came up with was, there's typical models for user authentication, but it's not as strong in terms of a standard model for what I would call instance or host identity models of identification, especially when you're dealing with multiple providers and multiple systems. And we thought this was ideal for something that maybe confidential compute could solve for. So what we think about is, user and instance identity is foundational to us securing sensitive data. Who you are, who you're working on behalf of, and where it's coming from is part of that classification aspect, as well as where it should go to. If we build what I call a chain of trust inside a confidential compute, we can do effectively this mapping that says, all right, service A can talk to service B, and the two together will build that informational system that understands what we should do. Now, when I look at how we manage this, there's the customer managed key that the bank informs us of, and that actually is what we use to create the authentication requests, who does what and how they actually talk to the systems. And that confidential compute system is where we're managing that mapping. So effectively, that managing of the mapping is in the node of confidential compute. It's a user, the application or the service, and the resource that's running the application service. And we can use it to both audit the change that we make, as well as the union of whether you should grant that handshake or not. Now, when we think about this, this is a general pattern of discovery. And you can see by the big boxes and arrows that this is very much a high level pattern, and it doesn't describe anything in intimate detail here. But what we really were trying to figure out was, if I create this service to instance mapping in a confidential compute, how would that work? Well, general principles are that the service A and service B want to actually talk to each other. And so service A would actually go to our confidential compute system and say, all right, get me a handshake or a token and authenticate that I am this service and I'm an implementation of this service and I want to talk to service B. The confidential computing node would actually take the mapping and say, okay, service A, you are actually cleared to talk to service B, and here's a one-time token to use with a time limiter on it. So we effectively put a TTL on it, so it's very short-lived. Give that back to service A presents it to service B then presents it back to our trusted system or in our confidential computing system, and they verify that the handshake is real, and they let the two decrypt the request, and it's authenticated. What we've done is we've moved the authentication of this information about the services away from being done inside of service A or service B. It's actually being done in a third system that's confidential compute. That mapping's done. And service A and service B can concentrate on what they're supposed to be good at, which is their processing information. That reduces the overall threat matrix in terms of what service A and service B can do, because the mapping and that verification of credentials is being done inside a confidential compute. And as a pattern, this is interesting to us because what it does is it leverages a lot of the key infrastructure with services, but also takes advantage of the idea that confidential compute is a protected and closed environment that can manage this mapping securely. So as I mentioned that previous pattern, that's just a general use case that we were thinking of an opportunity for confidential compute. There's additional things that we think could be used for in the future. Secret storage is one of the key ones, right? Managing keys, securing those keys in its system. It's just a generally natural fit for confidential computing. The second one is trust and integrity chain. The previous example demonstrated a chain of trust with service and instance mapping, but that can actually be expanded to integrity chains of who changes the data over time and what that information has happened. Or maybe you have a trusted vendor relationship across a data set and you want to understand where that went to. That chain and that management could actually be stored in terms of confidential compute. Another one is machine identity. Now, we were talking about instance identity and authentication, but when I say machine identity, there's actually putting the materials on the box themselves. Typically, that's done with certificates, but what if we actually use confidential compute to manage the certificates and the resources of those systems, and there's effectively check-in points? That confidential computing system could be the one that manages certificates and identities for those. Post-processing audit and log data. Now, audit data, log data, generally they're only as good as the data that's in them, and you typically need them to be readable and parsable to be able to make the most of it, creating those events, understanding what happened to the chain. But with that, you have clear text data that could pose a danger and a threat. If we're able to put that data in clear effectively to confidential computing systems, they can post-process that data, get the data out, maybe trigger those events in a secure way, and then dispose of that clear text data. And actually, you're just focusing all the processing in confidential compute. And then lastly is what we called a trusted enclave for data transforms, but really it's just a secure environment for aggregating data, multiple data sets that you want to put together and generate queries, searchable indexes, and something as simple as even machine learning. If you want to apply machine learning or other type of statistical algorithms to data, typically those algorithms need to operate on the data as in their natural form. If you can actually put that into a confidential computing environment that can actually do that processing, and you just worry about the output coming through and then dispose of the data that's inside that confidential computing node.
Thank you, everyone, for watching our show and our announcement.
So, to summarize, confidential computing is an industry wide effort critical for securing sensitive workloads. We're focusing on hardware based encryption for data in use with the goal of enabling it for any workload of any size. Our goal is to offer our customers a no compromise solution, the security you need without giving up on usability, performance, and scale. Thank you all for joining us today for this presentation.